So in our multiple choice, we're looking for the integral from 1 to 3 of f of x dx. The integral from 1 to 3 of f of x dx plus the integral from 3 to 10 of f of x dx is equal to the integral from 1 to 10 of f of x dx. The integral from 1 to 10 of f of x dx was given in the problem as 4. The integral from 10 to 3 was given, not from 3 to 10, so we have to flip the integral. So we're going to subtract the integral from 10 to 3 of f of x dx. And integral from 1 to 3 of f of x dx is what we're looking for. So we have the integral from 1 to 3 of f of x dx minus the integral from 10 to 3, which was 7, and that's equal to 4. So the integral from 1 to 3 of f of x dx is equal to 11, which is letter choice E. So the next example, we're looking at integrals where a, b, and c and d are in order. So the integral from a to d is given to be -7. The integral from b to d is given to be -2. And the integral from c to a is 17. Looking for, finally, the integral from b to c. So in order to get there, we have to take the integral from a to b of f of x dx plus the integral from b to d of f of x dx, which is equal to the integral from a to d of f of x dx. So the integral from a to b of f of x dx plus the integral from b to d, which was -2, is equal to the integral from a to d, which was -7. So the integral from a to b of f of x dx is equal to -5. And now to calculate the integral from c to d, the integral from a to b of f of x dx plus the integral from b to c of f of x dx is going to equal the integral from a to c of f of x dx. The integral from a to b was -5. The integral from b to c we don't know, so that integral is what we're looking for, integral from b to c of f of x dx. And the integral from a to c is the opposite of the integral from c to a. We have -5 plus the integral from b to c of f of x dx is equal to the opposite of from c to a, which is -17. Therefore, the integral from b to c of f of x dx is equal to -12. Which is letter choice A. The integral from 30 to 50 of f of x dx plus the integral from 50 to 100 of f of x dx is equal to the integral from 30 to 100 of f of x dx. Looking for the integral from 30 to 50 of f of x dx. Plus, given was the integral from 50 to 100 is letter B, and from 30 to 100 is A. So to solve for the integral of 30 to 50 of f of x dx, moving over the B, we get the expression A minus B, which then is letter choice B. This next example, h of x is an odd function. So when you're thinking about an odd function, or you're going from a -a to a of a function, that integral is always going to be 0 whenever you are working with an odd function. So for example, think of an odd function as x cubed. And when you're looking from negative to a of the integral of x cubed shading down to that x-axis, you can see that the areas are going to cancel out, and so then those areas will come out to 0. So to look at the integral from -3 to 5, we're going to look at the integral from -3 to 3 of h of x dx plus the integral from 3 to 5 of h of x dx. And that equals the integral from -3 to 5 of h of x dx. From -3 to 3, that's 0. From the 3 to 5, that's -2, which was given in the problem. So the integral from -3 to 5 of h of x dx is equal to -2. Which is letter choice B. The next example, the function in of G and F are both continuous, and the function is greater than or equal to 0, and A is less than B. So to draw a sketch, the function is all above the x-axis, and so looking at our interval from A to B, we're looking at that area from A to B where the function is above the x-axis. So for number 1, when we're looking at the integral from A to B of f of x dx, is that integral greater than or equal to 0? Well, since the function is above the x-axis, the area is all going to be positive, so yes, greater than or equal to 0. The second scenario, we're looking at the integral from A to B of f of x dx, f of x minus g of x dx, and is that going to be equal to the integral from A to B of f of x dx minus the integral from A to B of g of x dx? Well, if we have a negative sign and we want to flip the integral, then we're talking about the integral from A to B of f of x dx plus the integral from B to A of g of x dx. So the integral numbers switch and the interval becomes negative. So that's true. In the third scenario, we're looking at the function x to the 1/3, and let's say that a is equal to 0 and b is equal to 8. So to determine if this scenario is going to be true, we'll take the integral from 0 to 8 of 1/3 cubed dx, and is that going to be the same as the integral from 0 to 8 of x to the 1/3 dx being cubed? So the integral from 0 to 8 of x to the 1/3 cubed is just integral from 0 to 8 of x dx. Will that be the same as the integral from 0 to 8 of 1/3 x to the 1/3 dx being cubed? So to draw a sketch, the integral from 0 to 8 of x is just a triangle. That calculates out to make an area of 32. The integral from 0 to 8 of x to the 1/3, that's the cube root of x. Sketching the graph from 0 to 8, plugging in 8 to get 2. You can see that this is close to an area of a triangle. So approximately a base of 8 and a height of 2. So the area of that region is close to approximately 8 units. So the question is 8 cubed going to be the same as 32? And 8 cubed is not the same as 32, therefore we prove the condition is going to be false.